a star. Let's talk about Uranus and Neptune, okay? And again, I'm going to talk about these two planets together because they are very similar to each other, all right? So, and I don't need to say nearly as much about these planets because we don't know as much about these planets because they're way out on the outer edge. We haven't studied them nearly as closely as Jupiter and Saturn right here, okay? So, first up, let's talk about what they have in common. What do they have in common? What's some things you can say are true about both of these planets? What's similar here? Yep, they're both the same size, that's correct, and they are both blue, okay? Okay, they are similar in size, and they are both blue. Let me show you some closer-up pictures of them. Let me get me out of the way. Here we go. Here's a picture of Uranus. Here's a picture of Neptune. They're not exactly the same color, but they're both bluish. But just like Jupiter and Saturn, these atmospheres are mostly made out of hydrogen and helium, which are colorless. So that means, even though these atmospheres are mostly made of hydrogen and helium, there must be something else mixed in to give them this blue color. Can you guys figure out what these planets have in their atmosphere that turns them this blue color? Methane! That is correct. So the atmospheres of Uranus and Neptune are, give or take, roughly 5% methane. So there's a whole ton of methane in Neptune, and this makes me extremely excited to say, here we go, Uranus is full of methane. Yay! There's lots of methane in Uranus. Uranus is full of farts. Hooray! I'm a happy boy. All right. Hopefully that'll help you remember it. That said, a lot of people, including me, I used to think that meant that Uranus and methane smell like farts. But that's not actually true because methane itself is actually odorless. It's the other stuff in your farts that actually make them smell like farts. So I can't say Uranus smells like farts. It's just full of the main fart gas. Yay! All right, now, here we go. Let's take a look inside. The insides of these planets are almost identical. Here we go. Ignore, this was what we talked about last time, Jupiter and Saturn. Here, let me see if I can make this a little bit bigger. Blow that up a little bit. Bump. Bump. There we go. Okay, sorry, I'm getting a little bit of technical difficulties here. Okay, so let's check this out. If we look at this, the layers inside, there's only 3 layers. And the very, very, very middle one, let's call the rocky core. So these guys in the very center is the rocky core. I don't really need to say too much more about that. It's the same rocky core that Jupiter and Saturn had. It's the same kind of material that the Earth is made out of. So lots of iron and silicates. But again, under a lot more pressure than they are on Earth. So it's probably mostly solid, if not all solid. Probably all solid. On top of that, this sort of greenish blue area that they're labeling, that is an ocean. But unlike on Jupiter and Saturn, which had oceans made of liquid hydrogen and helium, the oceans on Uranus and Neptune are made out of water with ammonia. So these are much more similar to the oceans on Earth, but a few other materials, and there's a little bit of methane in there too, but it's mainly water with ammonia. So it's essentially very similar to industrial cleaning fluid. So you wouldn't want to go swimming in it because ammonia is kind of caustic. You don't want to hang out in there. And then on top of that, this top layer is just the atmosphere. Okay, so again, going through, we've got a solid rocky core, a liquid water and ammonia ocean, and an atmosphere mostly made out of hydrogen and helium, but with a little bit of methane that goes a long way to making that color blue. Okay, and the layers of Neptune are exactly the same. Now, Uranus and Neptune both have magnetic fields. Can you figure out which layer is making the magnetic field here? It needs to be liquid, and it needs to be able to conduct electricity. What is making the magnetic field of Uranus and Neptune? Which layer? Now, the core can't be making it because the core is probably almost entirely solid. So the entire core of Uranus and Neptune, unlike on Earth, is under so much pressure that it should be basically all solid. So there needs to be some other liquid there that can conduct electricity, and you might be overthinking it. It's the ocean. The ocean is mostly made out of water, and water can conduct electricity, okay? So the water in the ocean here, there's so much ocean, and it's spinning fast enough that it actually causes electricity to flow in that ocean at basically all times, and that gets a magnetic field forming, okay? One weird thing, though, that I should point out. Both of these planets, their magnetic field is very, very crooked, okay? It doesn't line up with their actual poles, right? So, on Earth, our magnetic field is slightly off from our poles. Like if that was our north and south pole, our magnetic field is a little bit crooked. On Uranus and Neptune, their magnetic field is almost 90 degrees off of their actual poles. It actually points along their equator, give or take. So they're very, very, very crooked. And we are not sure why they are crooked. One possible answer is that maybe these magnetic fields are both in the process of flipping. Because remember, our magnetic field flips every once in a while. But we're not sure that that's what's going on. And additionally, what I think is the coolest possible answer for that is that it seems like the conditions on these planets are right, that mixed into those oceans might be those oceans that are mostly water and ammonia and methane. There might be a layer of what they call liquid diamond. A layer of liquid diamond might exist in these oceans. What exactly does that mean? I am actually not 100% sure. This is very cutting-edge research that's discovered the conditions for this liquid diamond to exist. But the way that I understand it is, imagine that if you took a bunch of diamonds and melted it, and it was right at the melting point, so that as it flowed along, there were constantly diamonds, like solid diamonds, forming and melting all in that liquid. Essentially, what they're saying is that there might be diamond icebergs floating around in the oceans of Uranus and Neptune. That said, we're not sure on that. That's unconfirmed at this point, but it seems pretty exciting. I hope people continue to research that and tell me about that, because I would love to think of being able to take a submarine around some liquid. I mean, you probably wouldn't want to because the pressure would kill you, but it would be kind of cool to think of somebody swimming in diamonds. It's just kind of cool to me. But the reason I'm bringing that up is that the diamonds might kind of affect the magnetic field in a way that causes it to get out of whack. And so that might be what's going on. But again, we don't know why these magnetic fields are so messed up. Okay? Now, so let's take a look on the part of these planets we can see. Here's Uranus. Do you see a lot of detail? Do you see a lot of clouds and stripes and spots like we see on Jupiter and Saturn? Lots of detail here in this picture? Nope. Not a lot of detail. It's pretty plain, yeah. It's pretty plain. If we look at Neptune, you can see a little bit of detail here, but still not nearly as much detail as on Jupiter and Saturn. But don't let these pictures trick you. These pictures make it look like there's not a lot of clouds and storms and turbulence, but there is. There's probably tons of it, just like on Jupiter and Saturn. It's just much harder to see. And this will make sense if we think back to Jupiter and Saturn. Because remember, Jupiter had a lot of detail we could see. But Saturn's detail was harder to see because Saturn had less gravity than Jupiter, which made it so it couldn't compress its cloud layers tightly together. And so less of that detail was visible from space. It was lost deeper down in the atmosphere. So if Saturn had less detail visible than Jupiter, because having less gravity meant its clouds were less tightly pressed together, why would Uranus and Neptune have even less detail visible than even Saturn? What must be going on? Why do Uranus and Neptune have less detail visible? Yes. Yes, I think you guys are getting it. Even less gravity, okay? Even less gravity. So remember, Jupiter, the reason we can see all the detail is those cloud layers are pressed tightly together, so enough of that detail is close to the top of the atmosphere to see. On Saturn, with less gravity, the clouds are spread more out, so less of the detail is visible from space. And on Uranus and Neptune, which are even smaller, they have even less mass, so they have even less gravity. So those cloud layers are spread even more out. And so basically the detail is there. It's just so deep in the atmosphere, you can't see it from space very well. Neptune, you can see slightly better. And if you notice, if you look in real close here, you can see on Neptune faint stripes going across like the zones and belts on Saturn and Jupiter. We don't call them zones and belts here because they're not nearly as visible. And in fact, if we take a very enhanced picture of Uranus with other types of light that are invisible to the human eye, remember, like radio can penetrate deeper into clouds. If we do that, we get a picture like this. This one's actually using infrared light to penetrate deeper in the clouds. Here's a picture of Uranus, and we can see those stripes and some storms, okay? And this actually leads us to something super important about Uranus. Those stripes are vertical in all of the pictures of Uranus. What does that tell us about Uranus? What's weird about Uranus? If all of the other planets have stripes going this way, but Uranus has stripes going this way, what does that tell us about this planet? Yes. Yes. This planet is completely tilted on its side, okay? You know, the Earth is tilted 23.5 degrees. Uranus is the most tilted planet. It's completely tilted on its side, so it actually rotates like this instead of like this, okay? So its equator is right here going down, and the poles are here and here. So it's the most tilted planet, okay? Now, let me show you back that picture of Neptune again. So we can figure out what the clouds are made out of. The clouds of Uranus and Neptune are made of the same things, but because it's even colder on these planets than on Jupiter and Saturn, these clouds can be made out of different things. So there probably are some water clouds so deep in the atmosphere of these planets that we can't see them from space. But these clouds that we can actually see here are something else. They're methane, okay? Which is not a big surprise. Uranus and Neptune are the methane planets, right? So what's going on here? Because what color did I say methane was? I said it's blue, but these clouds are white. So can you tell what's happened to this methane to make it so it looks white instead? What's happened to the methane in these clouds? Keep in mind, it's very cold. What's happened to this methane? It got colder, so cold that it froze. This is frozen methane ice. So if you look back where Saturn is at a place where it's cold enough to form water ice and dry ice. But out here, it's cold enough for methane to start turning into ice. So remember, the methane on Titan was liquid because it was so cold. These planets are even further out than Titan was, so a lot of this methane at the very top of the atmosphere gets cold enough to actually freeze. So these are frozen methane ice clouds. They're crystallized frozen methane ice clouds, which is not that crazy, and here's a close-up picture of one. You might be like, whoa, frozen clouds, that's crazy. Snow clouds are frozen clouds. So this is like snow clouds, but made of methane ice instead of water ice, okay? And the reason it looks white here is that when you turn into ice, you can reflect sunlight very easily. So you're getting reflected sunlight off of those frozen ice clouds, okay? Frozen methane ice clouds. All right. Now, I do want to point out another feature. This is Neptune right here. What they're pointing out right here is a big dark spot. Here's another picture of it right here. It's a big oval, and can anybody figure out what it is? What is this big dark spot? See if we can remember from the other Jovian planets. What are we dealing with? Yes, that is a storm, just like the Great Red Spot on Jupiter. And the name for this storm on Neptune is the Great Dark Spot, okay? And one important thing about that Great Dark Spot is that unlike the Great Red Spot, this Great Dark Spot is not there anymore. So something seems to have broken up this storm. It doesn't seem to have broken up in the way that land breaks up a hurricane, but it has broken up. It's possible the turbulence ended up going against it just right to break it up, but we don't know why it disappeared. But yes, there are storms all over Uranus and Neptune, just like on the other Jovian planets. Now, somebody's asking me if I could explain why these clouds can be frozen but still stay up. I don't mean that they're one big solid frozen chunk. It's a bunch of tiny little particles, like basically snow particles, that individually are very light, and so the wind and air pressure is able to keep it afloat. So basically like snow clouds on Earth. Okay, now, all right. So again, everything that I've said so far applies to both planets, except for the slight differences that I pointed out. Like Uranus is all the way on its side, Neptune's not tilted like that. And the Great Dark Spot is only on Neptune, but Uranus definitely does have its own storms, okay? Those right there are storms that are only visible if you use infrared.